Hello there. This is a video on AP Calculus AB 2024 FRQ number 2. Uh, let's get started. A particle moves along the x-axis so that its velocity for positive time is greater than or equal to 0 rather, is given by this. This is calc active, by the way. Now there is one time t equal to tr in the interval from 0 to 2 when the particle is at rest or not moving. Find that time, and for this, is the particle moving to the right or left? Give the reason for your answer. So we know that what decides whether a particle moves to the right or left or when it is at rest, the velocity, right? So we need to find that when exactly is the velocity 0, and we need to find the sign of velocity between 0 and that particular time tr. So let me plug that in into the calculator. So if I do that, the velocity comes out, the graph comes out as rather something like this. And we can see that there are two times at which the velocity is 0. One is this and one is this, but they are interested from 0 to 2. So we will answer that this is that time. So up to 3 decimal places, the time comes out as 1.426 seconds. That is the value of t sub r, and they are also interested to know whether it's going to the right or left from 0 to tr. So you can clearly see that from 0 to this particular time, the velocity function is positive, and if the velocity function is positive, it means that it is going to the right, because positive velocity means going to the right. So that was a pretty straightforward question. This is how we do it. I hope this makes sense. All right. Let's go to part B. This one says that find the acceleration of the particle at 1.5. So obviously for the acceleration, we need to get the value of the derivative of the velocity, because the derivative of the velocity is the acceleration. Now there are two ways. Either you can manually do the derivative of this and then plug in t equal to 1.5 using the calculator, or you can just differentiate this right away using TI-84 at the point of 1.5. Either way, you're going to get the same answer. So let me just show it manually, the derivative. So ln derivative is 1 over t square minus 2t plus 5, and the derivative of t square minus 4t is 2t minus 4, and then the derivative of 0.2t is just 0.2. So this is the expression for the oh, anyway, they want us to show the steps, but yeah, I think either will work. You can either show the calculator stuff as well. You just have to show that this is the derivative. So yeah, this is where we plug in the value of t as 1.5. So let me just plug that in. So if we do that, I'm getting the value. In fact, that's an exact number which I'm getting is -1. So do we have units, by the way? I don't think so. They have mentioned units, so we'll just leave our answer here. And they're they're asking if is the speed of the particle increasing or decreasing at this time? Explain your reasoning. So whether the particle speeds up or slows down depends on the sign of a and t both. So since the value of acceleration at this point is -1, which is negative, we need to get the value of the velocity at 1.5. And don't you think we don't really have to do that again, because we already in the last question, if you see, we already have the curve at and 1.4 is the point where the velocity is 0, and after 1.4 approximately 1.4 1.5, obviously the velocity goes negative. So we know that the velocity at 1.5, whatever that value is, we are not interested. That's negative for sure. And if the acceleration and velocity are of the same sign, then the particle speeds up. So the particle is going to be speeding up, or the speed of the particle is increasing, in other words, at t equal to 1.5, because acceleration and velocity are of the same sign. Let's go to part C. This one says that the position of the particle at t is xt and its position at 1 is -3. So what is the position at 4? Let's show the setup. So we very well know that the position is nothing but the integration of the velocity function. So velocity function when integrated from what do you call it as? We will integrate from 1 because that's given as a reference point, and we'll integrate all the way till 4 because that's where we need to find it. And this is nothing but the this is nothing but the position, because the integration of velocity is the position, and we have to go from 1 to 4. We already know the expression for the velocity. That's ln of t square minus 4t plus 5 minus 0.2t dt, and this is going to be equal to x of 4 minus x of 1 using the FTC. This thing on the left side, we can use a calculator for this. So if we do that, we are going to end up with 0.197117, and that is equal to x of 4, which we do not know, and x of 1 is already given in the question as -3. So be careful here, we have double negatives. Double negative will make it positive. So 0.197117 is equal to x of 4 plus 3. And all we need to do is subtract 3 both the sides. So if we do that, the left side will become -2.803 up to 3 decimal places. So let's flip the omelette. So x of 4 is -2.803. Units are again not given, so we'll just leave the answer over here. So this is the position of the particle at t equal to 4. That's our answer. And finally, they are asking that find the total distance traveled by the particle, between 1 to 4, and we very well know that. Let me just quickly mark that what I was solving in each step, each question, so that it will be rather a little easy for you to track. Okay, so we know that the expression for the distance is nothing but the integration of the speed from 1 to 4. And what is the speed, guys? Speed is nothing but the absolute value of velocity from 1 to 4. So all we need to do, we already have the expression for velocity, by the way. So in your TI-84, use an ABS, or absolute value function, from 1 to 4. Absolute value of natural log of t square minus 4t plus 5 plus 5 minus 0.2t dt. That's what we are interested in. So if we do that, we end up with 0.958. Once again, the units are not given. So this is our answer. This is the total distance which is traveled by the particle from 1 to 4 seconds. 1 to 4 units rather. Seconds are also not given. It's not given that time in seconds. So anyway, I hope this makes sense. Any questions, please post it down in the comment section, and I'll see you in the next video. Bye-bye.